YouTube, guitar wiring 105, as in this is the 5th video. I'm trying to break this into really small chunks. So we've been talking about this. I've gone through how pots work. Got one sitting there in bits. I'll show you how that works and plugging it in and what a pickup does and how it works. So there is. So this one I suppose is going on to. This is your most basic pickup, which is just magnet, wire wrapped around it thousands of times. This is the start of that wire. This is the end of that wire. As you can see, these wires have been extended, so you can plug them in there. Right, so humbucker. There's one. Hey, we're there. Right, so as you can see, a humbucker kind of looks like two of these stuck together. Yeah. So what this is doing is, I'll do a super good drawing of a humbucker here. One coil, two coils. I have put a gap. Okay, I'll use the thick pen so you can see it. You can see it. So that's what we're looking at there. Here is a single coil. Here is a humbucker. Right. So all this is a magnet with a wire wrapped around it. Right. Well, what this is this is two of these together, but see on this one, for example, the wire is wrapped around it clockwise. This one, right? On this one, it's wrapped around it anti-clockwise, and the magnet's upside down. Basically like that. So it's imagine having that, and with that sitting next to it, right? So basically that's your principles. What you'll find is that, see, to prove this, here's a magnet, right? You know, magnets stick together. Well, it will stick to one of these coils because one of them will be the same as this, and the other one will be upside down. So it won't stick to that one. It wants to stick to that one, right? So this one is the opposite of this one. This one is basically the same as this. If you turn this upside down, it only sticks to this one. It won't stick to this one because you've turned it upside down. So the magnet's upside down, but it's not just the magnet that's upside down. The magnet's upside down and it's wired, instead of being clockwise, because you're looking at it from the top, this is clockwise. When you put it on that way, because you flipped it upside down, it's now going on to anti-clockwise. Yep. So the way a humbucker works is, you have, here's your output. Use a blue pen, a bit more space, right? So here's your jack socket. You've got the shield, and then you've got the hot. This is the shield, and this is the tip. Right. So the wire would go into one pickup, bang. This is what I didn't mention base plates earlier on. I said earlier on that this, see this one, right? It's just got a start and a finish. That's fine. Humbuckers have a metal plate on the bottom, right? So what happens is one of these wires, in this case, it's going to be this one here, the shieldy wire, and this one has to go to earth. So this is the earth, and this is positive. On this one, it doesn't matter which way around it goes. That's phase, which is something else, which we'll get to, right? So the signal, this goes to earth, and this and whatever the start one is actually connected to this metal base plate as earth. You'll notice that if you've got this wrong, when you touch the screws on it, it'll go because it'll be the same as touching the tip of your guitar lead. And then it goes out to that one, and then it goes in to the other coil. So it runs through this one, then it runs through this one and comes out. Yeah. And because these two have opposite magnetic fields, they both let through a signal. So if you imagine, here's your signal here, right? Let's say it does that, right? The other one, I'm making this sound more complicated than it is. Basically, there's you listen, and there's in this signal, right? There's interference, so it's like just like noise from expert. The other one, which is the same shape, right? So the other one is doing the same thing, and it's got the noise in it. These two things are the same. These are the sound waves from each of the signals. But because this one's flipped upside down, They both look the same, right? So what happens is this bit, once you put it round, it looks like this as well, right? But see all this interferencey stuff? So the signal you're picking up, the interference you picked up in this one is the same on this and this, but the signal is opposite, so they cancel each other out. But as you flip it upside down, so the signal becomes the right way around, see all this interference? It's inverse. So instead of being, I've got it kind of coming up here, it would come down like this. So they would cancel each other out, and that would cancel the hum, or it would buck the hum. So you would get like a reinforced signal. So these two things are picking up the same thing, but one of them's picking it up backwards, but then it's flipped round. But they're both picking up positive interference, you know, and then so when you flip that one upside down, the signal becomes the same between the two of them, but the interference cancel each other out. That's what humbucking is, right? So that's how a humbucker works in a circuit, and then it just goes to the volume control, and then with the tone control, and then to the output socket. The way the same principles as all the other things work. And if you want the two pickups, right? So I suppose go on to coil. I'll put coil splitting in this as well. So you're listening to both humbuckers, which gives you that fatter sound, because see in this bit where it's cancelled out, there's a lot of very high frequency stuff in there, that's why humbuckers are a bit bassier and ballsier than a single coil, because the interference is cancelled out, but unfortunately so is some of the treble. Yep. So if you're coil splitting, right, this pickup here has only got 2 wires, so people say, oh, you can't coil split that. Right. Inside this, obviously the signal runs through one of these coils, comes out it, runs through one of these coils, comes out it, and goes into this one. There's a wire that joins the 2 coils together, right? So that's this wire here in this case. So see if you put a switch in, right? You're taking this wire here, there's a switch, right? And it goes to earth. Right, so that this switch is off. When it's on, use a pencil. When you push the switch on, it connects this, right? So the signal doesn't go through this because the signal takes the shortest path. So the signal goes straight through there, bang, right? Oh, and then just goes through this one coil. So therefore, it sounds like that because you're not using this. You lose the hum cancelling, and you lose the fat sound, and you end up with just one pickup. So that is how you coil split a guitar. If I was to do it the other way, right, because, okay, this one is still, well, it's not, it's completely bypassed. Electricity goes from earth to positive, and it takes the shortest route. So if this switch is off as an open, it can't go through this, right? So it has to go through this coil to get to positive. It wants to get to positive. Whereas if you put a shortcut in there, it's got a choice of whether it goes straight to there or it goes through this and all. It's about the long way. It doesn't go the long way. It always goes the short way. So it just goes straight to there, and it's basically like this one isn't there. So that would basically give you would hear this coil. In the case of this guitar, you would hear this coil because this one, the earth is now bypassing it. If you were to do another pickup, just the same. So there's your earth, and then there's your output, right? There's your wire, right? So if instead of that, right? So you again, we're breaking into this wire. This is the wire that joins the 2 coils together. There will be a wire in here. If you take this to bits, there will be a wire in there. Do I have a guitar in bits? Is that pickup line there in bits? There is, right? This is a broken pickup, but it's there, so you can see this. So no, you can't see. So there's a wire missing from this. So there would be an in and an out. That one, that red wire there, should join onto there. So the signal comes in here, goes round the coil, comes out the red wire, goes in the red wire into this coil, and comes out the black one. So again, I'm breaking into this wire that joins the 2 together. See if you put a switch in here. Yep. So what it's doing is it's giving the electricity, it's coming through here, goes through the first coil, so you're hearing that, gets to here, and you give it the choice. Here, it can't go anywhere because the switch is off, but if you close that switch, again, always takes the electricity always takes the path of least resistance. So instead of it's not going to go all the way through this coil, which is difficult and long. It's going to go straight to the output. So it's going to, and so basically in that case, you're not going to hear that pickup because the signal's now going straight through like that, and straight to the output jack, or straight to the volume control, or whatever it is you put in there. That is coil splitting, and a push-pull pot is basically, how long is this video? 10 minutes. Next, push-pull pots in this is 105 in it. So this is 106. This is, yeah, whatever it is. See you soon.